one NCEA physicists and earth-space scientists are looking at the last topic for the heat internal today, which is energy efficiency. So first, going back to what energy is. So energy is required to do work, okay, applying force across a distance. And fuels are burnt to release that energy to allow that work to be done. So in terms of that concept, we also have the idea of useful and wasted energy. So useful energy is basically the energy that is going to be used to do what we want to do, okay? And the other forms of energy involved in the physical system are therefore considered wasted. And the wasted energy basically spreads out into the surroundings, be it sound energy, heat energy. So usually this wasted energy is in the form of heat energy, and that means that the surroundings become warmer as heat energy is released into them. So in terms of energy efficiency, the efficiency of a physical system is going to be the useful energy output divided by the total energy input going into the system. And it's a measure of how useful that device that we're using converts one form of energy into useful energy. Okay, and therefore the useful energy output is never greater than the energy going into it. So this ratio can never be greater than 1. So an example of that is energy efficient light bulbs. So they produce more of the useful energy, in this case light energy, that's what we want a bulb to do, compared to the wasteful energy, which is essentially heat. Okay, so they are more energy efficient than conventional light bulbs, which convert a lot more of the electrical energy into heat energy. And we can also use values to describe the percentage efficiency, which is basically the efficiency we've just calculated times 100. And the greater this percentage, the more efficient the device is. And just as before, as the efficiency cannot be greater than 1, so therefore the maximum percentage of efficiency can be no greater than 100%. You can't get more energy out than you put in. So ways to improve efficiency can be essentially, at least in terms of losing wasted energy to heat, is reducing friction, okay, in mechanical machines. So you can use a lubricant to reduce that, like oil, reducing electrical resistance in circuits, and reducing the air resistance, for example, in an aeroplane by using more streamline shapes, because therefore the friction is not converted into heat energy as effectively, or as ineffectively. And also you can reduce the loss to sound by tightening the loose parts of machinery as well, not just loss to heat. So this is where energy flow diagrams come in. It's basically a diagram illustrating the input energy, the device that causes that energy change, and therefore the useful output energy and the wasted energy. And there's a couple of examples coming up of that. So for example, a light bulb, the energy going in is electrical energy from the mains electricity. The light bulb is the device doing that energy transfer, and the useful energy is light energy, and the wasted energy, at least in this context, is the heat energy, and I guess a little bit of sound energy as well when you hear that hum, for example, especially in fluorescent lights. On a larger scale, a hydroelectric dam converts the kinetic energy of the water going down through the the dam into electrical energy, and energy is wasted in terms of the heat of the turbines and also the sound of the turbines as they convert the kinetic energy as the water passes through the turbines into electrical energy. So finally, that can also be illustrated in terms of something called a Sankey diagram. So a Sankey diagram is basically an energy flow diagram which we've seen, which shows how well the device uses energy. So basically the width of the arrows is proportional to the amount of energy that is being either inputted or outputted. Okay, so you can see on the diagram there that the width of the input is larger than the width of the useful output and wasted output arrows, and you'll also note that the wasted energy is always shown flowing downwards. That's just another way to illustrate energy efficiency and energy transfers.